Welcome, friends, in lecture 4, science lesson 10, gravitation. In this particular lecture, we are going to study with respect to thrust and pressure, starting with these topics. Now, what is basically thrust is? The thrust is nothing but a force acting on an object perpendicular to the surface. Generally, we speak a normal word as force, but this force is perpendicular to any surface of an object is called as an thrust, right? So the force is acting on the perpendicular on any surface, that is called as an thrust. Like as we are walking on the ground, so we are putting a perpendicular force on the ground, so we are putting a thrust, that is a force towards the earth, fine, and the same way the earth is reacting back. So these thrust that we are creating, like putting a nail and then hammering on it on the wall, so we are putting a perpendicular force on the nail by hammering on it. So this is called as an thrust, that is a perpendicular force. Like you are sitting on a table, so the table is perpendicular on the towards the earth's surface, and that is putting a thrust, that is a perpendicular force. The SI unit of thrust is Newton, as it is a force only. The next point is pressure. Now the thrust, that is a perpendicular force on the surface area, is called as a pressure. That means the force exerting on the particular area. Now if the area is reduced, then the pressure is going to increase, and if the area, because it is thrust upon area, so if area is going to increase, then that particular thrust is going to be decreasing, right? And like you are wearing a shoes which are having pointed nails, then this thrust is the area is going to decrease. So that's why the sports shoes are being worn by the cricketers, because it contains spikes. The area is reduced by spikes, as it is pointed, so the pressure is very high, so they can walk firmly. But in the same way, when somebody is walking on the snow side, they cannot walk with this kind of things, so they have to wear a big shoes, or maybe the skating, that is going to have a very large surface area. So the perpendicular force upon this particular large area is going to decrease the pressure, so they can walk easily. Otherwise in the snow they are going to penetrate their legs. So this is how the pressure and thrust can we can the unit of the pressure is the same one, Newton per meter square, and that is denoted as Pascal in SI unit system. Fine. The next topic after that is buoyancy. Now, what is buoyancy? The upward force, that is upthrust. Upthrust means the reverse force towards the object. The upward force exerted by any fluid. The upward force exerted by any fluid, or that is liquid, on the object is known as buoyancy. That means if you see whatever you try to sink inside the water, and that is not getting sinked upon, that means the easily, because it floats after a certain point. So this floating is just because of the buoyancy, like steamers are floating and all. So we have seen that the any liquid, the things do not sink that easily, like in air. Suppose if you jump from the first floor towards the ground, from the air side you will see that you are passing very fast, but like you are throwing an object, like you are throwing a ball, and you will be seeing that the ball is falling very fast in the air, but that same ball with the same height inside the water is not going to fall that fast. Why? Because the liquid is going to create the upward force, that is upthrust exerted by the fluid, is known as an buoyancy. So the upward force will be exerted on the fluid by the particular on that particular object. Fine. The magnitude of the buoyant force depends upon the density of the fluid. Density of the fluid, because if the density is more, it is going to exert a more upward force, that you are seen in the Dead Sea, because the density of the water is very high in the Dead Sea. So we can see that the people are not capable of sinking inside. They float on the water, and if you try it also, you cannot sink yourself inside the Dead Sea. Whereas in the ordinary sea water, you can easily sink upon, like that is submerged inside the water. The density is nothing but mass per volume, that is kg per meter cube, and grams per centimeter cube. These are the units of it. These are the three objectives of this particular thing, that the density of an object is greater, this sign is of greater, the density of an object is greater than the density of fluid, then it is going to sink inside. Fine, because the object is having a higher density, so it is not going to float on the water, it is going to sink. If the object is having the less density than the fluid, then definitely it is going to float on the water, on the surface of the water, like the wooden plank and all. Like if you put a iron ball here, in the case the object density is higher than water, then it is going to sink inside the water. Where in the case of a wooden plank, the object density is very less compared to that of the fluid, so it is going to float on the water. Even the oil is having a lesser density then, so it is going to float. The densities are equal, that is of fluid and the object, then it is going to turn stable after a certain point, maybe sinks at certain point, and after that may get stable after a certain point. So what is the relative density? That is density of the substance upon density of the water, that is called as an relative density. Again, relative density means density of any substance upon density of the water. So this is how we measure the relative density of any substance. The next is Archimedes Principle. Now, Archimedes Principle, Archimedes was an scientist way beyond, and he has found many different things in which this was a very famous principle, and it contains a very good story also behind. That he has to find the density of the certain thing, that is a gold put inside the crown of an king, and he solved that problem. So you may see on the YouTube there are videos available for the same. So Archimedes Principle, what is in principle is about when an object is immersed fully or partially in a fluid, it experiences an upward force that is an equal to the weight of the fluid displaced by it. That shows that if you suppose if you have a stone and you tie up a stone and fully immerse inside the fluid, which is a completely filled beaker, you may see that the beaker is been overflowed because that stone is been put inside, and that is going to put an upward force by the fluid on the stone, that it is not going to allow that stone to pass through easily. That means it is going to make the reverse force on the stone. So this amount of fluid which has got displaced out in the from the container, if you weight that particular liquid, that is going to be the same with respect to the amount of stone that has been thrown out. That means that much decrease in the weight will be there. Fine. Next is the uses, that is application of the Archimedes principle. Now uses in the it is used in the designing of the ships. That means the ships are being designed in a manner that it does not sink just because of the principle of the Archimedes. Lactometers, which are used to determine the purity of the sample of the milk. That is also on the basis of the application of Archimedes only. These lactometers, that is measuring the quality of the milk. And the hydrometers are used to measure the density of, like in the battery we are going to measure, we are supposed to measure the density of sulfuric acid. So how we measure is by hydrometers. So hydrometers are used for determining the density of the fluids. That was 3 uses and application of Archimedes. Next is the sums regarding that. The first is 10.6 as in sum. So we'll see 10.6 sum. A wooden block is kept on the tabletop. That is, on the table this wooden block is been kept. It is of 5 kg, but the dimensions are 40, 20 and 10, as you are able to see. In figure A, you are able to see it is placed on surface of 20 and 10, and the height is 40. In the case of B, it is placed on the surface of 10 and 40. Here the height is 20. So first it is 10 and 20 as in length and breadth. In second case it is 10 and 40 in case of length and breadth. Fine. So by the wooden block on the table top and made lie on the table on this particular dimensions A and B. Fine. So you need to find out the pressure exerted and ordained. So I have solved the sum and kept here. This is the mass of the object is 5 kg. In figure 1 you are able to see length and breadth is 20 and 10. So first of all, force will be how much? The force is equals to mg, that is going to be 5 multiplied by 9.8, that is 49 Newton. Now area will be equals to 20 multiplied by 10, that is going to be 200 centimeters square, and dividing by 10,000, this is going to be 0.02 meters square, because 100 and 100 division, it is going to be divided by 10,000. Fine. So 0.02 meters square. Pressure is equals to, we have just learned the formula, pressure is equals to thrust upon area, that is thrust upon area. So this is a thrust, that is a force, this is a perpendicular force is 49, and the area is 0.02. so that answer comes out to be 2450 in case of an A. In this other case it was 40 and 20 in figure B, so that comes out to be 800, right? That comes out to be 800 centimeter squares, that comes out to be 0.08 meter square. If it is by chance 10, then it is going to be 400, so it is going to be 0.04 meter square. In certain figures, in certain books it is given as 40 and 10, in certain books it is given as 40 and 20, so you may consider accordingly. It might come as 800 or and 0.08, or 400 and 0.04. So 49 divided by 0.08 comes out to be 612.5, or otherwise if it is 0.04, then the answer is going to be double. Fine. So this answer is going to be 1225 meter Newton per meter square. So it can be an either answer, you calculate according to the book that is you are having it. Fine. The next sum is 10.7 as an sum. This is about relative density. Relative density of the silver is 10.8. It is given, and the density of the water is 10 raised to 3 meter cube, kg per meter cube. What will be the density of silver in SI unit? Fine. So silver density we are supposed to find. Here the density of the silver, relative density is given as 10.8. So it will not have no units, because it will be cancelled, and density of the water is 10 raised to 3 kg per meter cube. So the relative density, the formula is relative density is equals to density of the substance upon density of the water. So relative density multiplied by density of water, relative density multiplied by density of water is equals to density of the silver, that is substance for us in the present. So density of silver will be equals to relative density as 10.8 multiplied by 10 raised to 3, and obviously that is going to be answer in terms of kg per meter cube. But in case of grams per centimeter cube, it will be 10 raised to 3 is going to get removed, because it will be multiplied by 1000 and divided by 1 lakh, unit 10, 100, 1000, 10,000, lakh, and 10 lakh, sorry. So 10 raised to 3 upon 10 raised to 6, and it is going to get cancelled. So 10 raised to 3, 10 raised to 3 is also going to cancel. The answer will be 10.8 grams per centimeter cube. Fine. So this is we have solved almost all the chapter. Fine. And PDF of exercise is also sent to you, so kindly solve those question answers. Thank you for this particular lecture.